So I'm late hitting record on the video today, but this is page 2 of the notes. You didn't really miss anything from page 1. It's just more practice of the same stuff. So number 4, plus there's more room to work on this one. F and G are twice differentiable functions. What do you think twice differentiable means?
You can get f prime prime, f double.
Right, you can find a second derivative. But that means there's no sharp cusp. There's nothing undefined. Like everything is well behaved here for the first 2 derivatives. All right, h of x equals f of g of x. So Tootsie Roll Pop, h prime of x. Let's see, outside in. So the outermost is f prime. And then I leave g of x alone. But then I chain rule that and take the derivative of g. By the way, quite a few of you got the bonus right on the test. And I usually don't do partial credit on the bonus, but I did this time because there was also quite a few people who got like really close but messed up one little thing. So I gave you 3 of the 5 points. All right, so h prime of 6 means wherever there's an x, go 6. F prime of g of 6 times g prime of 6. They did give me 2 rows on this one, so I got to be a little bit careful here. There's a lot of numbers in there. What's g of 6?
4.
4.
I don't know why I blanked over it.
And then I'll use that 4 as the input to f prime. F prime at 4 is pi. It's a table problem, so they can put any values they want in there and not worry about what crazy function would have given you that. G prime of 6 is E. So okay, that's a why is that different than my my notes? Looking at notes from a different teacher and I see the mistake. Yeah, f prime at 4 is pi, and g prime of 6 is e. The notes I'm looking at just grabbed this, f prime of 6, even though it clearly says f prime of 4. So even a seasoned calculus teacher can make a mistake just tracing around. Pi e, that's a weird answer, but who cares? We're fine. I'm not going to call out anybody just because they messed up. Let's see. Why don't you try C? I don't press pause. You try C. It's another chain rule problem, but it's f of, so it's a little bit different. Try C. Again, outside in. The derivative of the outside is f prime. Leave the inside alone, and then chain rule it. The derivative of the inside is f prime. Then plug 6 in for x everywhere, and just be careful because there's lots of places to look on the table, and to not get confused on where you're looking. Let's see. Do we need to do part D? You tell me, what rule would we be using here? Not the chain rule for part D. What's going on? What's that little dot mean? Multiply, so product rule. So actually let's just write it as h prime of x and then we won't plug in 4.
Does that mean x on the outside of all of that?
No, because they're not parentheses. So just find h prime of x. So there's the answer to D, but look at an E, f prime of 4, f prime of 6, and we want to know somewhere, we want to know if between 4 and 6 the derivative is 0. What do you think?
Okay, well, the function h of x is continuous because it's twice differentiable.
Yep.
And f prime of 4 is pi, and f prime of 6 is negative 5. And 0 is between the values. So there's at least one value of x in the interval 4 to 6, which is between.
That's exactly right.
0. Yeah.
The 0 is in between pi and negative root 5 because that's positive, that's negative. So 0's got to be in there somewhere. As long as f, we should say f prime is continuous, because that's what we're looking at here. So it's f prime is continuous, and we know that because it told us f is twice differentiable.
But negative square root of 5 is negative 2.2 yada yada yada.
Mm-hmm.
Negative 2.2.
So there's a 0 somewhere between positive and negative. So actually this is the Iavt, the intermediate value theorem. And so we have to say there must be at least one value on 4 to 6 where f prime equals 0 by the intermediate value theorem. If it starts positive and goes negative, it had to cross 0 somewhere. So that's a throwback several weeks ago. All right, there's no way we're going to get through all of this, which is fine because it's just repeat, 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 repeat. There's a chain rule. I've done the chain rule. 5 and 6 are, well, different kinds of chain rules. 5 and 6 are chain rule questions. But let's turn to number 8. And let's see if we can do 8a. And then we'll be done. Both of those are chain rules. So if I want h prime of 3, I need h prime of x first. And this is an easy spot to forget the chain rule. So the derivative of f is f prime. Now I've said chain rule like 4 times in relation to this problem. So what else do I need to include as part of that derivative?
The other part. Yeah,
Times 2. The chain rule. Plus g prime. Okay, we did g prime. That's the outer wrapper. So we're done messing with the outer wrapper. One step at a time. So leave x squared minus 3 alone. But then chain rule that to 2x. And then it's a matter of plugging in 3 at some weird places. So that becomes f prime of 6 times 2. Plus, I'm going to move the 2x to the front. That would be 6 times g prime of 9 minus 3 is 6. So now I'm to the table. F prime of 6 is negative 3. G prime of 6 is 2. And safe stop, done. Don't want to mess up the algebra from there. Not that that would be a tricky one, but we don't want to mess it up. Okay, we'll stop there. I mean, you can see what's coming. You can see it. They're all either quotient chain or product or some combination thereof. Again, nothing new, just all stuff we've done.